Okay, a lot of times when we're using lasers, we want to take an image of the beam. Nowadays we have imaging sensors that are very cheap. The cheapest ones you can get are usually commercially available webcams, but they're not suitable for direct viewing of a beam because they have a lens which would focus the beam and change its parameters. So I'm going to show you how to turn this into this, which is a webcam with the window and the lens removed, as well as the little LED that would light up to indicate that it's on. We'll get rid of that so that we don't get any leakage of that background light onto our device. So it's a fairly straightforward process. It will vary a little bit depending on the particular model of webcam you use. I'm using this HD model from Logitech, the C525. So I don't really care about software that came with it or any of those details. I'll just rip that all apart. Okay, so the first thing I have to do is remove the faceplate. The faceplate is held on by glue. So if I can get a screwdriver or a razor blade, I can pry it off. This is not designed to be taken apart, so this initial part can be a little bit tricky. But I'm just trying to pry in there. Be careful I don't stab my hand. Okay. So I removed the little faceplate. You can see there's a little bit of glue, double-sided tape, I'm not sure what that is, holding it on. And then there are 4 screws that I'll need to remove using a small Phillips head screwdriver. 1, 2, 3, 4. So I'll set these aside. I'm going to reuse these. I don't have to. I could just remove the faceplate entirely and leave it off, but I find that it's nice to reassemble it with the faceplate. It makes a little cleaner package and also helps block out some of the room light that might otherwise hit the imaging sensor to give us a little bit better contrast when we're using the device. Okay, and so once I've removed the screws, the faceplate will come off, side plate as well. So now I've got my my bracket I'll set aside. I'm going to return to that. This edge I'm going to just throw away. You might choose to keep it. Here's what's inside. This is actually the entire webcam. The rest was just for aesthetics. The first thing I need to do is remove this little box. That box is the lens enclosure. And actually I can remove the, it's magnetically held on, so if I just pry it a little bit, I think it's a combination of magnets and some clips. Okay, so I've removed that cover, and now I have the lens. The lens is it's an autofocus lens, which means it's somewhat flexible, can move back and forth, and you'll see that if you push on it. It wiggles around. So my job here is to pry off the lens. I'll take the entire assembly with it. There's some wires that wrap around it that are presumably for the solenoid that is actuated to move it back and forth. And it really just rips off. It's only these thin gauge wires holding it on. So I'll pull it off, remove any stray wires. I might be able to just pull them off or use clippers if necessary. And now I've exposed the bare CCD. So at this point it's suitable as a laser camera. However, before I go any further, there's one thing I'm going to want to do. There's a diode here. That's a light emitting diode that turns on when the camera's operating. So it's not a huge deal, particularly if I've left this little black box around the CCD. That, I say CCD, it's actually I think a CMOS sensor. But the imaging sensor there is fairly well shielded from the LED, so we don't get stray light. But nevertheless, if you have some optics here, the LED might bounce off of that and illuminate your sensor. So I'm going to remove or short out that LED. Okay, so I've got the device plugged in and the computer's reading it. You can see the LED is lit up, and on the computer I can see a blur from the light illuminating the sensor. And my concern here is that this LED can produce stray light that hits the imaging sensor, reducing the contrast. So there's a couple ways to deal with that. One is the low-tech solution, a little piece of electrical tape. Cover that up and do a reasonably good job of reducing that. The other is to desolder the LED. Okay, so the LED is held on. It's a surface mount LED, and there's pads on either side of it. So desoldering it is fairly tricky. You'd have to melt the solder on both sides simultaneously. If you're particularly skilled with the soldering iron, you may be able to do that. I haven't been able to do it straight in the direct manner, but what I have found is that if I apply a little bit of solder, I can bridge the gap between the electrodes. I originally did this to try to short out the LED, assuming that that would prevent it from illuminating. And the first time I tried to do this, what I found is that the solder actually provided thermal contact to both sides, caused the LED to desolder and adhere to the soldering iron, so that I was able to simply remove it, there we go, from the board, and the LED is now stuck to the end of the soldering iron. So I'll call that a success. Here's the device after I've desoldered the LED. It's currently outputting to the computer, but as you can see, there's no LED, so no light to reduce the contrast on the imaging sensor. So now at this point, I have my webcam functioning properly. I'm going to reassemble it just for looks, aesthetics, ease of mounting it and such. So I could just screw this back on, but there's one more modification I'm going to make. If I look at the surface of this lens cover, it's a little hard to see, but there's actually a piece of glass there. And that glass is helpful. It keeps dust off of the sensor. But in our case, we're not going to want it because it's going to cause reflections of the laser, and those reflections can produce unwanted interference patterns. So I just poke through with a screwdriver and remove that piece of glass. And now I'm free to reassemble it. It's still pretty easy to keep dust off of the sensor. When I'm not using it, I can just put a piece of Scotch tape over the place where that cover glass was. There you go. I've now got this packaged up nicely, just like it originally was. If I want to mount this in a traditional optics mount, the easiest way to do that is probably to drill number 8 through hole right here in the top of the mount. I can then screw that into a standard post. Put it in a post holder, and I can swivel it as necessary. Here I've got my lens space covered up with plastic tape while I'm waiting to use it. And here's an example where I've set up a laser with some neutral density filters to prevent the webcam from saturating. Take those out for the moment, and we can see on my computer screen the output of the webcam. So I've got the beam centered on the imaging sensor. So I'll go ahead and drop in those filters, turn off my lights to reduce the... And now I've got a nice spot on my... Here's an example of illuminating the detector directly with the output of a laser. I've put a few neutral density filters in place to make sure that the image doesn't saturate. And I could take a picture of this, analyze it using some computer tools, and figure out if I've got a Gaussian beam here, what its Gaussian beam width is, and such. And here's an example where I'm centering my camera on the diffraction pattern from a circular aperture. So this is an airy pattern. I could very easily measure, for example, the diameter of the dark rings and use the calculation of the interference pattern to figure out the size of the aperture. This is all from the $55 webcam that I purchased online and spent half an hour modifying to make it available as a laser camera.